Okay, so hello everyone. In this video, we will cover SJF and SRTF, shortest job first and shortest remaining time first. So in this video, first we will see SJF with non-preemptive, then SRTF with preemptive and SJF with preemptive. So let's understand the concept of shortest job first scheduling algorithm with the numerical example. So in this numerical, first we have given here 4 processes P1, P2, P3, P4. Their arrival time and burst time is also given. This will be given to you in the almost all numerical problems. What we need to find is completion time, turnaround time, waiting time and response time. So we have the algorithm here, shortest job first. In shortest job first, we have the criteria of burst time. This means we check the burst time. Shortest job means a process whose burst time will be lower. We will select the process. This means we will run that process first on the CPU, and the mode is non-preemptive. Non-preemptive means if we give one process to the CPU to execute, then that whole process will be executed without any interruption. Once it starts, it runs completely until it finished. Now let's start with the help of Gantt chart, because it will make the process very easy. If you see any numerical on this type of algorithm, first you will make Gantt chart. Time will start from 0 always. So let's start with the 0. So at 0, which process had arrived already? Now first you have to check if there is any process arrived at 0 or not. There is no process that has arrived at 0. So from 0 to 1, you can simply make it idle. Idle means CPU is idle from 0 to 1 time limit. If there is no process, then obviously CPU will be idle. Now at time 1, we are at time 1. So I checked at 1, then P1 and P3 arrived at 1. This means P1 and P3 both arrived at 1. Now should we pick P1 or P3? So far that I have to use the criteria of burst time. So first we check burst time of P1, it's 3. P3's burst time is 2. So which one is shortest out of these two? That's 2. So we will select P3 first because its burst time is lower. So now the mode is non-preemptive. This means it has to execute completely. Executing completely means its execution time is 2. So we execute it for 2 time units. 2 means we are at 1 and it will take 2 more. So it will take 2 units of time more. So 1 plus 2, then it will become 3. So at 3, P3 got executed completely. Now we are at time 3. So at time 3, first we have to check that which process have arrived already. P1 has arrived already. Now P1 arrived at 1 but hasn't executed yet. So we will keep P1 here for now. Other than P1, which process has arrived at 3? If we check at 3, then yes, P2 has arrived at 2. So P2 and P1 are already present in the ready queue. Now if these two processes are in the ready queue, then which one to select? Then we will select it using burst time. First check which process has arrived. If only one has arrived, then there is no logic of burst time. We have to run that process only. But if multiple processes have arrived at that time, then we have to use burst time. So in this case, we have P1 and P2. So let's check burst time. P1's burst time is 3 and P2's burst time is 4. Then P1's burst time is less out of these two. So we will get P1 executed for 3 unit of time. So 3 means from 3 to 3 plus 3 means 6. So P1 will get executed. So now P1 is complete. Now we are at time 6. Check which process has arrived at 6. P4 came at time 4. So it's already there. This means there are 2 processes in the ready queue, P2 and P4. Now which process to select out of these 2? Again we will use criteria of burst time. So check out time of P2. It's 4 and for P4 it's also 4. This means both of their burst times are same. So in this case, when P2 and P4's burst time is same, then which one to select? Whenever you get conflict like this, then take a step back and check their arrival times. Check which one has lower arrival time, which means which one came first. Then you will find out that P2 came first at time 2 while P4 came at time 4. So which one to select out of these two? P2. Because although burst time is same, we are selecting P2 because of arrival time. In case of arrival time would also be same. Just as an example, if we assume that arrival time is also same, then in that case you can simply use process ID, that the one with the lower process ID you can select it. So in this case we are selecting P2 first, and then we have to run P2 for 4 unit of time. 6 plus 4 equals to 10. So we ran P2 for up to 10 time units. Now after that there is no problem because only P4 is left. So we select P4 and it also needs 4 unit of time. So 4 unit of time means 10 plus 4 equal to 14. So P4 will be completed at 14. Now let's write the completion time. First of all, when did P1 get completed? Check on the right hand side of P1 in Gantt chart. It's 6. So it got completed at 6. P2 completed at 10. Now check for P3. P3 completed at 3. Now P4 got completed at 14. So this is how we can calculate the completion time. When completion time is calculated, then for turnaround time and waiting time, just use the simple formulas. Turnaround time equals to completion time minus arrival time. So for P1, 6 minus 1 it is 5. For P2, 10 minus 2 it is 8. P3, 3 minus 1 it is 2. For P4, 14 minus 4 it is 10. Now for waiting time, the formula is turnaround time minus burst time. So for P1, turnaround time is 5, burst time is 3. So it comes out to be 2. And for P2 is 8 minus 4, 4. For P3, 2 minus 2 equal to 0. For P4, 10 minus 4 equal to 6. So this is the waiting time. Now for response time, you don't need to find response time in case of non-preemptive, because it will be equal to waiting time. In case if they ask you, then how to do calculation of response time? The time at which a process gets the CPU first time. For example, when did P3 get the CPU first time? At 1. And you can check the left hand side, and P3 arrived at 1 also. So 1 minus 1 equal to 0. This means you don't have to calculate it, because it will come equal to waiting time. So in this question, they can also ask about average turnaround time. Average turnaround time is just total of all turnaround time. It will be 5 plus 8 plus 2 plus 10 equal to 25 divided by number of processes, which is 4. So it comes out to be 6.25. Now what is the average waiting time? It will be 2 plus 4 plus 0 plus 6 equal to 12, and divided by 4 equal to 3. So this is the average waiting time. Now we are moving forward to SRTF. So here I have 4 processes: P1, P2, P3, P4. Arrival time and burst time is given. Now we will start it at time 0. First we have to check how many processes arrived. You will move to criteria later. You will use criteria when you have the competition. Competition means there are many processes competing. At that time I have to use burst time. If I got one process arrived only, then there is no competition and you can execute the process. So here first we say check at 0. Only P1 has arrived. So if P1 is alone at 0, then no need to check the burst time. Obviously I have to execute P1 only. Then in shortest remaining time, first you don't have to run it in one go, because it checks again and again if there is any other shortest like shorter process arrived in the ready queue or not. So we will run it only up to 1. Then its remaining burst time is 4. 1 unit is completed, so 4 is still left to be executed. At time 1 I check again, and that which other process arrived or not. Check again. P1 is already here because it ran only 1 unit, but P2 also came in the ready queue because P2 arrived at 1. Now here you have to check burst time. P1's remaining burst time is 4, but P2's burst time is 3. Now you have to select P2 and preempt P1. This means send P1 again to the ready queue and execute P2. This is a little bit complex algorithm, because after every step it checks if smaller process arrived in the ready queue or not. So in this case we will run P2 at, we ran it from 1 to 2. Remaining time becomes 2. 1 unit got executed, so 2 is left. Now at 2 check again that which process arrived. We check again. P1 is already arrived. It's already in the ready queue. P2 has also already arrived. P3 also arrived and came in the ready queue. When we compare all 3 processes, then out of all 3 processes, which has lowest remaining burst time? P2 has the lowest with 2 units remaining. So it means P2 will run again from 2 to 3 for 1 time unit. Then just 1 time quantum is left for P2. Now at 3 we will check again which process are in the ready state. P4 will come at 4. P2 has the lowest remaining burst time with 1 unit. So P2 will get run again and will get completed at 4, because when you run it from 3 to 4 it got completed. So P2 got completed, then you can remove it from the ready queue. Now at 4 we will check again which process has arrived. We checked at 4. At time 4 P4 has also arrived in the ready queue. Now you will compare again like that which has the lowest remaining burst time. P4's burst time is lowest with the 1 unit. So we will run P4, but its burst time is already 1 unit only. So obviously it got completed at terminated, and after that we are at 5. So check at P1 and P3 are left. So P1 and P3 are both left. Out of these two we will run the one with the lowest remaining burst time. P1 and P3 both have remaining remaining burst time of 4. Now in this case there is a conflict, which one to select first, because both remaining burst time is same. So I told you earlier that whenever you get confusion in burst time, you can move to the arrival time. Check whose arrival time is lower. So out of these two, P1's arrival time is lower because it came at 0 while P3 came at 2. So we will give it priority here and we'll run P1. After that at 9 P1 completed, only P3 is left, so there is no need to run P3 one by one. You can completely execute P3. So P3 will get completed at 9 plus 4 13. So this is how we have to solve this. Now first write the completion time. Check when each process get completed. Now where did P1 appear last? We have to check on its right hand side. So here P1 got completed at 9. P2 appeared here last, so it get completed at 4. P3 came at here and got completed at 13. P4 came at here and got completed at 5. So completion time is P1 for 9, P2 4, P3 13, P4 5. For turnaround time, we complete completion time minus arrival time. So 9 minus 0, 9, 4 minus 1, 3, 13 minus 2, 11, 5 minus 4, 1. Now let's calculate waiting time. Waiting time is what? Waiting time is equal to turnaround time minus burst time. So it will be 9 minus 5 equal to 4, 3 minus 3 equal to 0, 11 minus 4 equal to 7, and 1 minus 1 equal to 0. So this is how we calculate the waiting time. In case of non-preemptive, waiting time is same as response time. So no need to calculate separately. Here the formula of response time is when process got CPU first time minus arrival time. Check where P1 is written first time. It's here in the Gantt chart. So check it in left side that CPU at it got CPU at 0 and it's arrived at 0 also. So 0 minus 0 0, and P2 will be 1 minus 1 equal to 0. So when did P3 get the CPU first? At 9. But when did P3 arrive? It came at 2. So 9 minus 2 equal to 7. P4 had arrived at 4 and got CPU at 4. So 4 minus 4 0. So response times are different from waiting times. To calculate average turnaround time, total all turnaround time, it will be 9 plus 3 plus 11 plus 1 equal to 24, divided by 4 equal to it becomes to 6. Now calculate average waiting time, it will be 11 divided by 4 equal to 2.75. and if they ask average response time also, 0 plus 0 plus 7 plus 0 equal to 7, 7 by 4 equal to 1.75. So this is how we can solve all these questions. Now we will discuss a UGC NET question. We are going to discuss a question that appeared in UGC NET. There are three processes, P1, P2, P3. Arrival time is 0, 1, 2 and burst time is given 7, 4 and 8. And what they are asking is the Gantt chart for the preemptive SJF. They have given 4 Gantt charts in the option. You have to find out the correct Gantt chart according to the preemptive SJF solution. So first of all, you have to focus on the algorithm. Algorithm is shortest job first. It's shortest job first, but along with that it's preemptive. This means when it's shortest job first along with the preemptive, then you can call it SRTF also, which is shortest remaining time first. I'm making a new Gantt chart for here from the starting. The Gantt chart always start from 0 because we also always start the time with the 0. Now at time 0, which process has arrived? Which process are those that are already arrived and ready? Which process has already arrived at 0? Only P1. Only P1 has arrived. So first of all, we all run P1 here, but here it's preemptive. So in preemptive, you will have to keep in mind that we will run P1 but for only 1 unit time, because after 1 unit we will check again if there is any other sorter job or ready or not, and then reduce 1 from the burst time, because P1 ran for 1 burst time unit, then the leftover is 6. P2 also came in the ready queue at time 1. So P1 and P2 both are in the ready queue. So which one will be selecting first? We will select the shortest first, the one with the lower remaining burst time. So out of 6 and 4, which one has lower burst time? P2. P2 has lower burst time with the 4 units. So we will get P2 executed here, and CPU will execute it only up to 1 time unit first. You have to run only up to 1 time unit. Let's suppose it ran from 1 to 2. Now P2 is remaining time is 3. Now at time 2, check again which process has arrived. At time 2, all 3 processes has already arrived and are ready, but which one is shortest out of all these? That's still P2 with remaining time 3. So you have to run it P2 again. Let's say P2 let's say you ran P2 again for 1 time unit, and now its remaining time is 2. P2 got completed at time 5. Now when P2 got completed, then which one is shorter out of these remaining 2? P1 has remaining time 6 and P3 has burst time 8. So P1 is shorter. So we will run P1 again, and for how much time we will run it, we can run it up to completely for remaining 6 units, because there is no shorter process to interrupt it. So P1 will completely at 5 plus 6 11, then obviously only P3 is left, so there is no need to run P3 one by one, because it's the only one left, there's no one else in the competition. So when there is no one in the competition, then you can run it completely. P3 will run completely for 8 units, completing at 11 plus 8 equal to 9. So our final Gantt chart shows of P1 from 0 to 1, then P2 from 1 to 5, then P1 from 5 to 11, then P3 from 11 to 19. Then this matches with the option B in the given choices. So this is all about the concept of shortest job first with preemption and non-preemption and SRTF. So that's all for this video. We will meet in next video. Until then, bye bye.